Okay, in IM1 today we're going to start talking about absolute value inequalities. And these are a little more intense than just compound or even just regular absolute values, so you want to make sure that you're following all the steps. So before we even get started, I want to remind you that you can't make any decisions about your absolute value till it's isolated, meaning it's all alone. Okay? It's all alone. And you also don't want to do anything. This is what we learned in the other chapter. Nothing goes into an absolute value or comes out of an absolute value. Okay? And all absolute values are positive. Okay? So they can't equal a negative. So these are the kind of things you need to remember from the section on absolute value inequalities or absolute value equalities. But these rules still apply here. Okay, when an inequality contains an absolute value expression, it can be written as a compound inequality. That's what we learned about in 2.5. Okay, so the inequality, the absolute value of x is less than 5, describes all real numbers whose distance from 0 is less than 5 units. So here's, what do you think that would look like? Well, if this is 5, then less than 5 would be everything in between. So right away I want you to notice that this is an AND problem. Okay? And instead of just being 2 points, the answer is everything between the 2 points. Okay, when an inequality contains an absolute value, it can be written as an OR statement as well. So this one describes all real numbers whose distance from 0 is greater than 5. So if you think about the graph, it's going to be everything that is farther away than 5. So how do you remember this? Well, this is just a reminder that you want to isolate, so get your absolute value all by itself before you decide if it's an AND problem or an OR. It has to be alone. Okay? You can make all the moves you want before, but you don't decide if it's an AND or an OR problem until it's all alone. So, once the absolute value is alone, the symbol that is next to the absolute value tells you if it's an AND or an OR. So, another funny thing that we do, so if you think of the word AND, we're going to go less than. Less than. So if it's an absolute value is less than, then you know it's an AND problem. Okay? Same thing with the other one. If we have greater than, we're going to say an absolute value is greater. Greater, we're reading from the absolute value. Greater, it's an OR problem. Okay? Read from the absolute value just like you read from the variable. Everybody got that? Another way to remember is that AND comes before OR in the alphabet, but I think this AND and OR is much better and it'll get into your brain a lot quicker. All right. Okay, so we're going to solve the inequality. Step 1, get my absolute value all alone. So I get the absolute value of x is less than 2. This is possible. So I'm going to split it. I get x is less than 2. Now, what do I do on the other side? So this is where you're going to change things up even more than you did before. So first thing I'm going to do is my inside stays the same, exactly the same, but I'm going to flip my sign, change number 1, and I'm going to make it a negative. Okay, so you have 2 changes to make. Make sure you make them. So now if I'm going to graph this, and I forgot to tell you, this is right here, less than, the absolute value is less than, so it's an AND problem. So I'm expecting barbells. So let's graph it. One thing about absolute values is you want to look for the smallest number first. Negative 2, x is not equal to, but it's greater than. Then you graph this one. It's not equal to 2, but it's less than. So that's the way that your answer would look Whoops. And yeah, there's the answer. And okay, I'm going to erase this slide so you can see all this cool stuff. There you go. And now you can see that they did the same thing as me. That's side 1. And then we're going to do side 2. We're going to flip it. And you do the opposite sign. And then you're going to write it as a compound inequality. So that's pretty cool. Okay? All right. Okay, so again, before we get to this point, we have to get it alone. Okay, so we have the absolute value of x is less than or equal to 3. It's less than, so we're going to do and. We just have to remember that it's an and. X is less than or equal to 3. X is greater than or equal to negative 3. And we're done solving. So we're going to graph it. Negative 3 is the smallest number, and it's greater than that. And then positive 3 is over here, and it's less than that. And so our answer, boy, looks like, didn't get the highlighter going there. Here we go. There is our answer. Okay, so there is your answer. And go. Oh, here's the answer. Okay, so we're going to get ready on this one. Again, the absolute value is isolated, so we can say this is less than because the absolute value is less than. Okay, so it's an and problem, less than. Okay, so we're going to split it, and we get x minus 1 is less than or equal to 2, and x minus 1, flip your sign, negative 2. So remember that this part inside the absolute value is always the same, but we have two changes with an absolute value inequality. So make sure you do both of them. So now we're going to solve, and we get x is less than or equal to 3, and we're going to add 1, and we get x is greater than or equal to negative 1. So to graph that, we're going to go to the smaller number, negative 1, and it's equal to but greater than, and then we have 3, and it's less than. So one thing that you might notice on absolute value inequalities is they are either both open or both closed, because you're flipping a sign that either has an inequality on it, like this, or you have one like this. So they will both be closed or they will both be open. And there you go. Okay. All right. So now this is going back to making an absolute value. So I thought this picture was adorable, so I added it in. A pediatrician recommends that a baby's bathwater be 95 degrees Fahrenheit, but it is acceptable for the temperature to vary by this amount by as much as 3 degrees, which is not a lot. So the midpoint is also the ideal that they want, and this is the allowed variance. And we talked about this with manufacturing, but it works in temperatures too, okay? So the ideal is 95, and it's acceptable to have a range of 3. So once you've settled that, then you can solve the problem, and T is the actual temperature, but I put an X. So now we're going to have the solution. So they used a T, but that's okay. All right? I will never mark you wrong for putting an X when it says to make a T, because I do it all the time, so that wouldn't be right. So this makes sense that it's between these two temperatures. Remember when we did compound inequalities, the word between means it's probably an and statement. Do you remember what word makes it include these numbers? Inclusive. Okay? So as much as means inclusive. So there's the range of acceptable temperatures. And there we go. Okay, so this is a problem from your book, and they want you to come up with the equation. So remember, the normal body temperature of a camel is 36 degrees. That's an important fact that you need to know. And it can vary by as much as 3 degrees. Now, when you're not sure what sign to make, think about, would it be okay for its temperature to vary by 10? No, it's going to die, so we're going to say less than. And that will help you decide whether it's less than or equal to. Okay, so I want you guys to do the journal problems on page 56, just number 1 through 5. And I'm going to, while you're doing those problems, I want you to just leave this up here. This tells you all the steps. Okay, remember to ask yourself if it's, and, or, and then you're going to remember to flip and put the opposite operation over here on this side. Remember to keep this the same in all, and go ahead and solve. So this is just an example to help you with the steps. So go ahead and give yourself a few minutes to do numbers 1 through 5. Okay, so here's number 1 through 5, and those are the answers. So if you got any of these wrong, then go ahead and wait, and I will go through them after the end. But if you got them all right, good for you. You're ready to do your homework. So check your answers and decide if you need to go on. Okay, so let's go over these problems. First thing I notice is that my absolute value is all alone. So I go less than, yes, less than. So I know that that's an and problem. I'm going to split it. Y plus 2 is less than 8. Y plus 2 is flip it and negative 8. Then I solve, minus 2 to both sides. Y is less than 6. Minus 2 to both sides. Y is greater than negative 10. I always graph my negative number or my smallest number first, so I kind of set where it is on the graph. Open circle at 10, and it's greater than. Then I'm going to put a circle for 6, and it's less than. I want you to remember that it doesn't matter to me how many dots are in between here on the graph. You can just graph them away from each other, and then make sure that your graph is very obvious, that your answer is what's in between the open circles. Okay, over on number 2, this is also isolated. So I look at that and I say, the absolute value is greater. Oh, this is an or problem. So I'm going to split it, and I get q over 3 is greater than 2. Q over 3 is less than negative 2. I'm going to multiply both sides by my denominator, and I get q is greater than 6. Same thing over here. I'm going to multiply by the denominator, and I get q is less than negative 6. Negative 6 is my lowest number, and it's less than negative 6. Okay, and then positive 6 is over here, and it's greater than. This is an or problem, so I'm expecting goggles. So it's okay, and I know that I got it probably right. Okay, for the next one, we have to isolate our absolute value. So I'm going to subtract 10 from both sides. I get 3. Absolute value of 2a plus 5 is less than or equal to 27. Divide both sides by 3. I get the absolute value of 2a plus 5 is less than or equal to 9. I'm finally ready to split, and I go absolute value is less than, so I see that this better be an and problem. And we're going to talk about the exceptions on the next video, but just know that that's why we have to make sure we know what it is. So I'm going to split it. We have 2a plus 5 is less than or equal to 9, and 2a plus 5 is greater than or equal to negative 9. So subtract 5 from each side. I get 2a is less than or equal to 4, so a is less than or equal to 2. Okay? Then over here, minus 5 from both sides. I get 2a is greater than or equal to negative 14. Divide by 2, and I get a is greater than or equal to negative 7. So I'm going to put an equal sign at negative 7, and a is greater than, and then I'm going to put a close sign at 2, and a is less than. So my answer would be like barbells, okay? Not with that though. All right, over here we're ready to split, and I can see that again it's an and problem. So I'm going to split it. I get y minus 3 is less than or equal to 4, and y minus 3 is greater than or equal to negative 4. Add 3 to both sides. Y is less than or equal to 7. Add 3 to both sides. Y is greater than or equal to negative 1. Again, a closed circle at negative 1, and y is greater than. I always read it right before I draw my line in my circle. And a closed circle at 7, and y is less than. So there is your answer. Okay, so for this one, we're going to start by isolating our absolute value. So we're going to add 4 to both sides. We get the absolute value of 3 plus r is less than 4. We're going to split it, and make sure you stop here and say, is it and or? And this is less than, so it's an and problem. This matters a lot when you get to exceptions, but it also matters in that you want to make sure that your graph turns out looking like it should. So when you see the word and, you expect barbells, okay? Because if you go past an exception and finish it, you want to make sure you think back to this and make sure that your answer is correct. And we'll talk about that in the next video. So again, 3 plus r. The steps for or problems are exactly the same. You're going to split it. The first one is exactly the same without the absolute value signs. The second one, you flip this and you change the sign on this. Okay? So I'm going to subtract 3 from both sides. I get r is less than 1. I'm going to subtract 3 from both sides, and r is greater than negative 7. Open circle at negative 7. Open circle at 1. Make sure your arrows match what it says, and the line should be in between. Okay, time for your homework. If you didn't understand, watch a couple of examples again. Good luck.